Hi, Dr. Math Tech here with another part of SPSS. This time we're looking at some regression. We're going to do some simple linear regression analysis and try to predict a couple of things and come up with a prediction equation for how we can predict. So let's say, for instance, I have this problem here. So I'm looking at this case study. It says that the assistant principal wants to know if students' cumulative GPA on an 8-point scale can predict a final exam grade if they're in their 5th grade science class. He wants to predict the final exam score of a student who has a GPA of an 8.0. In order to be successful, be sure to include a prediction equation, an APA-style regression table, and APA-style scatter plot. So the first thing we have to do is go over our assumptions here. So the assumption is that data has to be on the interval scale. The relationship between the independent, which would be our x, and our dependent, which would be our y variable, is linear. And then we have all the variables should be a normal distribution. This is just basic descriptive statistics. One thing we want to see is the data normal. Of course, we'll check that. We just do some histograms for that. So let's say, for instance, I just go over here, go to graphs, go down to legacy, and I want to do histograms. So I'm looking at GPA. So it's I want to reset that. I have something old in there on it. Look at GPA. So I'm gonna hit GPA, put that normal curve on it. That's gonna give me a good indication what we're looking at. And as I look at the GPA here, what I'm seeing is, okay, I'm looking at something here that looks fairly normal. If you see here, it pretty much fits that normal curve. I don't think it's going to be out too much. So that looks like that one may pass the test of normality. You can do a little variance test to make sure of this, but I'm just looking at it here just to see if the data is fairly normal. All right, let's look at the other side here. So we want to see if we could predict their, what was their final exam score, I think it was. Let me go back and check. We wanted to predict the final exam score. So let's look at the final exam here. Go to graphs. I want to go down to histogram, and I want to take that one out. And I want to look at that final exam score, and hit OK. So as I look at the final exam score here, you see here that looks pretty normal too, I would think. So it looks like we don't really have any violations here. So actually, I guess I would take this out. So they no violations, it looks like, from what I can tell. Everything looks pretty normal there. Relationship independent variable. Well, how can we tell that? Well, we can do a scatter plot to look at that. So let's pull up our data again here, and okay. Let's see here. Look at scatter plot here. So we can go back to graphs. Let me see. Down the scatter plot. Just going to do a simple scatter. Here we're trying to predict the final exam score, right? So let me reset this. I want to predict the final exam score, so I'm going to use this, and GPA is what I'm going to use. So I'm going to use the GPA to try to predict the final exam score. Let me see what that looks like in the scatter plot here. So as we look here at the scatter plot, it looks like it could be fairly linear. So you can see here there is some kind of straight line, like we might get some kind of line, some kind of positive correlation line or linear line that we could draw some kind of straight line through here and then hit a couple of these points. I'll be very close. So I feel pretty good about that assumption. So I think we're okay with that. All right, so data it's an interval scale. We know that the relationship between the independent variable x, which in this case is our GPA, because we want to see the we're trying to see if we can use the GPA to predict a student's final exam score. And remember, the GPA here is on the 8-point scale. So I'm using the GPA. So based off your GPA, which is our independent variable, can either pick, the dependent variable, which is y. So we have x. Our x here is the GPA, and our y here would be the student's final exam in their science class. So the next point of that, then we just get some descriptive statistics here. So I just have some of the descriptors here, but before I got that far, I'm gonna show you how I actually got there. We actually have to do some calculations here. So let me go back to SPSS here. And, okay. Can I get back to my, here we go. All right, so I'm going to go into analyze. I'm going to analyze. We want to do a regression. And when I do regression, I want to do a linear regression. So I'm going to go down and click here, linear. You see there's a lot of other things in here, but we're not messing with any of those right now. So we want to do a linear. I'm going to click on linear, the dependent variable and the independent variable. So the independent variable, in this case, we're using the GPA as the independent variable, which is our x, and the dependent variable, which means that GPA, pending you get this GPA, this is what your score is. We're going to predict that final exam score, which would be our dependent. Okay. And let me see what else we have here. I'm going to click on statistics. You can do the model fit. I want some descriptors there. Okay. We don't need none of the rest of that. Let's see, continue. See, as far as plots, is there anything that I would like to have here? As far as plots, we're okay. Of course, we want to do dependent, and guess we could look at this one if we wanted to. I guess the dependent and the adjusted. I think this should be the adjusted predicted. Well, no, we'll leave that one off for right now. Don't need to do that. We can come back to that a little later. So we have that. Like I said, we have our descriptive statistics here. That's taken care of. Let's hit OK and see what we get. All right. So as we click here, and got a couple of things going on here. So let's look. So we have the descriptive statistics of the final exam score. There's the mean, the standard deviation, and what N is. Then we have the okay. Computer's a little slow today. Then we have what the correlation is. So is there a correlation here? Correlation is 0.613, which is I would guess starting to get pretty strong. That's about 61.3%. And then we have the final the significance value here of 0.002, which is fairly significant, which means that we're going to reject that null hypothesis. And our null hypothesis was that no linear relationship existed between these two. So we're going to be rejecting that already. We see that. And then, of course, this is just our end. So the biggest thing about this is that we want to be able to predict. So this is the correlations is very similar. I mean, this regression is very similar to doing a correlation in that we're going to identify, is it positive or negative correlation, what kind of strength. But the power of this is the actual prediction value. And what we get from this, we actually have a equation Now, the prediction equation is of the form, usually I think it's y hat equal to bx plus a. Very similar to your y equals mx plus b that you did in algebra. Pretty much the same thing, but they write it a little bit differently here in statistics. So, but we still use that same slope formula to help us predict our value here. So you see here we have some ANOVA things right here. We have the F here, which is 10.823 with a significant value of 0.004. Again, meaning that this test is also significant. And we go down here, we get these correlations here. And these correlations are what's, not these correlations, I'm sorry, these coefficients. Well, when we write this equation, we need those coefficients, and we're going to talk about how you read these off these coefficients. So we have a coefficient that the constant value is 47.56, and that the dependent variable is 1.2, or the slope is 1.224, and we'll be able to put that into the equation and come up with an equation for this particular predictor. So I look at that. I'm gonna go back to my other sheet here. Let's see if I can pull that up both at the same time. It'd be nice, so we can actually do some comparison here. All right, I think I got it. All right, so oh, come on. I think it's acting a little weird today. All right, so you see here I just wrote the descriptive statistics, which was found in the table above here. I'm trying to get to. Okay, so there's the descriptive statistics. Then we talked about here. Remember our null hypothesis is that no relationship exists between final exam and GPA. So we rejected that null hypothesis. We did not accept it. We rejected the null. And with rejection of that null, then we assumed the alternate hypothesis, which says a relationship exists between final exam and GPA, and so the correlation is not equal to 0. And clearly the correlation is not equal to 0 because we got the correlation to be 0.613, which is fairly good. So the results of our statistical procedure, we do have a significant linear regression prediction with the p-value being less than 0.05. So remember I was telling you about a minute or two ago that we have this equation. So we have I have y prime is equal to a plus bx. Well, where do we get these coefficients of a and b from? Because we know x is what the dependent variable and y is the, x is the independent variable and y is the dependent variable. Well, where do we get a and b from? Well, if you notice in your output, I told you a second ago that we actually get the coefficients out of this model. So the coefficients here, if you see here, there's b, and we have a constant. Well, our constant here is what? A. So a would be 47.56, and then b, b part here would be this other, which is the GPA, which is 1.24x. So now we have a equation of the form y prime is equal to 47.567 plus 1.224 times some x. So a simple linear regression was calculated predicting the final exam score based on their GPA. So a significant regression equation was found where we have an F, and this is our our degrees of freedom in here, 1 and 18, is equal to a 10.832, which was a significant value because remember our p-value here was actually 0.004 with an r squared. We want to make sure we report the r squared of which is basically our standard error, which is 3.75 here. I'm sorry, it's not our standard error, but our model is 3.75. And then we had the predictive exam scores. So the predictive exam score is basically equal to this equation, the 47.56 plus 1.244 times the GPA. So the average final score is actually increased by 1.2.4 points depending on the person's GPA. So then we go down to the last part here. We was talking about the decision regarding the null hypothesis. Yes, we reject the null, meaning that we did not accept it because the p-value was below 0.05. So we reject the null and we consider the alternate hypothesis that a relationship does exist between exam and GPA. So the correlation is not equal to 0. In conclusion, the regression has a positive direction and has a strength strength of 0.375 with a value of 10.832 degrees of freedom. Here degrees of freedom, and a significant p-value is less than 0.05 of the regression. So this is the formula to actually figure out the regression. And if you recall back in our original question, it says he wants to predict the final exam score of a student who has a GPA of 8.0. All right, so I said, okay, given the data we were given, we used that based off that the correlation and using all the data that we had, we came up with this equation. So now I place an 8 in because that's what my GPA is, and do the math on that. Multiply 1.224 times 8, that gives me 9.792, and then I add that to 47.56. So that gives me roughly a final exam score of a 57.359. Well, y'all, even though you have that exam score, you want to go back and see, does that actually make sense? Well, so they say if this person got an 8, has an 8 GPA, they should have a score of probably about 57.39 on average. Remember, this is based off the strength of his test. Based on your data is how good your actual prediction will be. So if you have really strong data, really good data that's really normal, then this right here will be a pretty good prediction. So what I always like to do myself is like to check against myself. So let's look in here. So if somebody basically if they have an 8 GPA, that they should have probably pretty much like a 57, right? So let's look here. Do I have an 8 GPA? All right, so this one is a little bit above 8. If you notice here, their exam score was about a 56. It's in the neighborhood, I guess. This person here is, let's see, 8.7. They have a what? A 57. That's pretty much in the neighborhood. This person right here almost has an 8 on the head. And if you notice there, what do they have? Like a 57.8. So remember, our prediction here was that the person was going to probably have about a 57.3. This one right here said they have a 57.8. No, that's not bad at all, I don't think. I think that's pretty strong. I mean, a couple of tenths of a point. So I feel pretty good about that prediction model. I always do that to go back and safeguard and check against it to see how that looks based on what I did. So that's pretty much it. And you have the tables. You can write this up however you like. And I think this would conclude linear regression in SPSS. Hope you have a good one. Bye.